Hello, geometry class. In this video, I'm going to cover chapter 7, section 6, sine and cosine. So we had talked about tangent, and we had learned that tangent is the ratio of an angle in a right triangle. Tangent's ratio is opposite over adjacent. So given an angle, the tangent of that angle is the ratio of opposite over adjacent. Well, there's two other trig functions. There's actually more than that, but there's two other trig functions we're going to learn in geometry, and that is sine and cosine. So sine and cosine are just like tangent in that they're a ratio of an angle. So it's all about the angle that sine is of. So in this first part here, you see that sine is a sine of a here. So we're looking at this triangle from angle A. And that's very important because depending on what angle you're at will change what leg of the right triangle is opposite and which leg is adjacent. So A being here, the opposite leg will be this side over here. The adjacent will be this. The hypotenuse will always be the same. But if we were looking at it from B, then the opposite and adjacent will change. So when we were looking at tangent, tangent was opposite over adjacent. Well, sine and cosine are different. They're going to be different ratios. Instead of opposite over adjacent, sine is going to be the opposite leg divided by the hypotenuse. Opposite divided by hypotenuse will be the ratio. So sine is a comparison of the opposite leg and the hypotenuse. Cosine will be a comparison of, or a ratio of, the adjacent leg and the hypotenuse. Okay, adjacent and hypotenuse. So sine, opposite and hypotenuse, opposite over hypotenuse, cosine, adjacent over hypotenuse. Okay, and then tangent, what we learned before, was opposite over adjacent. Okay, and with that, we actually have, there's three sides to a right triangle or any triangle. But on a right triangle, there's three sides: hypotenuse, opposite, and adjacent. And with that, with sine, cosine, and then tangent, we actually have a comparison of all three of these. We have any two of these three legs are now compared with one of these trig functions. So if I'm looking at the hypotenuse and the adjacent, well, that's covered by cosine. If I'm looking at the opposite and the hypotenuse, that's covered by sine. If I'm looking at the opposite and the adjacent, that's covered by tangent. So there's a trig function for each of these, any two of these three sides, and that's why there are three trig functions. There's actually more, but not that we're going to cover. So what we're going to do in this is we're going to find sine and cosine of r in example 1, and I just need to write the ratio of those trig functions. So we are going to use this. Oh, not that. This. We're going to use this again. This trig table that will be attached. PDF. A PDF of this will be attached, and we're going to be using that to find these. Nope, we don't need that. Again, with the trig table. We will use those later, maybe in the next example, but we don't need them for this example because sine of s, so this is the angle we're looking at, is opposite over hypotenuse. That's the important part. Opposite over hypotenuse. Sine of s is opposite over hypotenuse. So it's 63 over 65. Okay, and you'd then get your graphing calculator out. Clear that. You do 63 divided by 65, and the ratio between those is 9.69. Okay. Cosine of r, so they're asking for sine of s and cosine and sine of r. So I did this. Something is wrong here because, okay, yes, sine of s and sine of r. Let me change this. Sorry about that. There's a typo in this. It should be sine of s and sine of r. Okay. So we're changing the angle we're looking at. So from S to R, but we're going to keep sine as the ratio. Okay, sine as the function we're looking at. So now that we're over here, looking at r, we're still doing sine, so it's opposite over hypotenuse. So 16 over 65. On your calculator, you do 16 divided by 65, and that is the ratio. Okay. Example 2, cosine of u and cosine of w. So we're going to do the trig function cosine, and we're going to do it for u, and then we're going to do it for w. Cosine is adjacent over hypotenuse. So looking at u, adjacent is 18, hypotenuse is 30. So you're going to do 18 over 30, which is the same as 3 over 5.6. Don't even need your calculator for that. Okay. Cosine of w, so now we're switching to this angle, because the angle that we're looking at is very important. Cosine, the adjacent now for w is 24, and it's going to be over 30. The hypotenuse stays the same, which is 4/5, 0.8. You don't even need your calculator for that. So either of those. All right, example 3, word problem. You want to string up a cable to make a dog run from 2 corners of a building. Okay, so you're stringing up a cable to make a dog run from 2 corners of a building, or allow, I should say, that allows your dog to run from 2 corners of a building. Write this and solve a proportion using the trigonometrical ratio to approximate the length of the cable you need. So we know the angle here is 35, and we know the length of the side opposite that angle is 11, and we want to know what x is. The right angle is here, so this is the hypotenuse. So x is the hypotenuse. So I'm looking at this, and I see that it's opposite and the hypotenuse. So there is a trig function that relates opposite and hypotenuse, and that is sine. So sine of 35 degrees is equal to the opposite 11 over the hypotenuse x, unknown. And this is actually where the trig table is going to come into play, because on this trig table, I'm going to look for sine. Now we're in the sine column of 35. I'm going to scroll down to 22, so I'm coming over here. Sine, I'm in the sine column. 35, it's right here, 0.5436. Okay, so I can replace sine of 35 with 0.35, whatever that was, 5736. So I'm going to do that eventually. 0.5, what did I choose? 5, okay, yeah, 574. I'm just going to do 3 decimal places, round this up. It's giving me 4, but I can write 3, it's fine. You can do 4 if you want, but 3, you need to do at least 3 here. But before I did that, because sine of 35 is a number, eventually going to be a number, I can treat it like a number. So I'm just treating it like a number by multiplying. First, I'm going to multiply x by both sides, because I'm trying to solve for x, and it's in the denominator. So then I have x times sine of 35 degrees equals 11. Sine of 35 degrees will be a number, which we looked up, 0.574. I can divide both sides of the equation by that, and that's what I'm doing. And that's canceling it out on this side. We have the x equals 2 now, and it's 11 divided by sine of 35 degrees. So I'm changing the sine of 35 degrees to 0.574. Whenever I use a value on this table, other than sometimes when, very occasionally, like this 0.5 would be an example. Anytime you have a 0.5 or 1/2, 0 or 1, you don't need to do this, but any other time you use a value. All these are approximated values. So that means that I'm going to, there's another half. So the 1/2 show up occasionally, and there's 0 and 1s on the ends, and there's a 1 in the middle here for tangent. But other than those values, 0, 1, and 1/2, any of these other decimal values are approximations. All of these are approximations, except for those 3 exceptions, 0, 1.5, and 1. So whenever I replace a trig function here with its approximation, I need to change the equal sign to approximately equal to, because now this equation is rounded because this was rounded. Sine of 35 is exact, that is rounded. Graphing calculators you don't have access to, that's why you have the table. But you might not have a graphing calculator. Will give you the value that we're using. But you see how it goes, it's an irrational number that goes on forever. So we're rounding it, so this is now an approximation. The last step would be to take that 11 divided by 0.574, and get the 19.16, we are okay with 1 decimal point, or one decimal point for the final answer. I want more than one. I want 3 decimal points until you get to the final answer, because I don't want you to round too soon and get a less accurate answer. It was 19.16, which I rounded up to 0.2. 19.2 feet is the answer. Okay, so I have bookwork and a work packet, which I will attach to the Google Classroom assignment, and that is sine and cosine. Thank you, and good day.